Hi everyone. I'm about to show you a presentation full of new concepts and with a lot of code. So please bear with me. I hope we're gonna have fun on this next 25 minutes and hopefully learn one or two tricks. But before I start, I want to announce a little disclaimer, a big disclaimer. Whenever I want to show you is under construction right now. The main intention here is to put some hype on the language that we love and show the upcoming amazing features that may or may not come to JavaScript and all the problems that a new feature can bring to the TC39 in order to ship those features to ourselves. That said, I want to present you Back to the Future. So, I'd like to start my presentation asking a tricky question. What is this? So, in ECMAScript, this has different semantics than this in other language, where it most refers to the lexical scope. So, in the global scope, this on JavaScript refers to the global object. So, in the browser is window, and the web works itself, Node.js, module.exports, and so on. But what about this inside a function? Well, depends. It depends how and where this function is called. So I will show you my Meowct component, and it's a very simple class. It has just one parameter and one method. So if you look on this line 15 here, you will see that whenever I click on the button, I want to console log the cat.poll property, but actually my intention is to print the button element, but since the context here is the button event, I will print out undefined because the button element doesn't have the poll property. So how to make this predictable? So reasoning the this inside JavaScript is pretty tricky. So we can achieve this by doing two things. First, function.prototype.bind, which binds the context of the first parameter you send to the bind function to the method you want to call, and arrow function. So I will show the previous example with these two techniques. The first one, as you can see here, again on this bottom line here, I'm explicitly bind the cat instance into meow method, so I will print out properly. The sound is pretty. I will print out the button element there, and then with arrow function it's similar. But you will see that I don't need to explicitly bind the this because it takes the lexical this in consideration. Then you have the button console properly. So the thing is, arrow function removes a lot of complexity in order to predict the this inside a function. But we still have two cases that we need to explicitly bind this on a function. The first one is this one. Whenever we, for example, on the line 2, you see that I have a new object called obj, but since I don't extend this from the object prototype, prototype, I don't have has-on property. So whenever I want to check if I have the X property inside the obj, calling has-on property on line 4 will throw a typing error. So to fix this, I need to extract this function from the object prototype and then call passing the first parameter as a context and the second parameter the first parameter for the function. It's kind of tricky. And the second one is whenever I want to extract a method from an object, I need to explicitly call the this context. So how can we cover those two cases in a more natural way? So this is the hook for our first proposal. Bind operator. This bind operator comes with two syntaxes, the unary form and binary form. The binary form takes whenever we have on the left side, whenever it turns from the left side as a context, it binds to the right side of the operator. So that example could be rewritten on the lines 5 and 10, yeah, the last one, like this one, so it works. When it's shipped, of course. And the unary operator is a little bit different. It takes the base of the reference you're passing and set this as the context of the method. So this line 2 could be the sugar to cat.meow.bind and passing cat inside. This is really cool that because we can compose functionalities by virtual methods. So you can extract those virtual methods and compose them like this iterable library. Or on this implementation, RxJS5, there is a way to do this on there. I don't know if they still encourage this. I won't do it, but it's still an example. And for example, on this jQuery-like library, you can just extract the functions you need and then use there. It's nice because you just download your bundle. You just bundle only the functions you need, and plus it makes it easy to extend those libraries. Bind operator is a good solution for virtual methods, but it relies on this to be bound. So how can we do the same, how can you compose the functions the same way without relying on this? So let's suppose I have this function here, this functionality that whenever use input something, I need to sanitize this input and textualize all the digits I receive and then console log those. So usually this is a way that we can do this, but to make it readable, we end up having a lot of intermediary variables. And I think someone can say, this could be written without using this variable, but will look more or less like this. It could be tricky because we may have a lot of nested functions, one inside the other. I don't like this. So to solve this problem, I want to present to you the second proposal. Pipeline operator. It's a syntax sugar for function composition. It creates a streamlined chain of functions, and it's backwards compatible. So remember this, this example here. Using pipeline operator, I can rewrite this one with this code example. So you can see on the top of the pipeline chain, you have the subject, and then you start to pass this subject to the next step, and then the result of the next step will be the subject for the following step, and so on and so forth. And this code could be the sugar to this. And it's amazing, like you don't need to write all those variables. What if that textualized number needs to receive a second parameter? For example, if we have the need to only textualize zeros and ones, how can we do that here? So one possible solution is to create an arrow function to receive one parameter, and then inside this arrow function you bind the second parameter inside this. But it creates a syntax overhead because you need to wrap the arrow function with parentheses. So it's kind of tricky. And what if I need to process the sanitize, and what if the sanitize function needs to process the entry on the server? So I can await this. But it's tricky because this line here, it's not clear how this would desugar to. I can desugar this to await the sanitize call to with the parameter from the previous step, or await for the sanitize, and then the result will be a function that then I will send the parameter. So we have a tricky question, it's tricky to reason about which one of those could be the sugar too. Yeah. To answer those questions, I need to, and we need to understand the two competing proposals we have for this, because the minimal proposal doesn't cover this completely. So I want to present you the first one, which is Smart Pipeline. The Smart Pipeline solves this in two ways. You can see here that we have on line 2 the topic style and the line 4 the Barry style. Whenever you need to use parentheses or square brackets, you need to use the topic style, and then you need to use the hash token to as a placeholder for the subject for the previous step, from the previous step. And whenever you don't need anything, it's just straightforward. You just need to use Barry style. It's worth mentioning that this sharp token is subject to change, it's not final one. What about currying? If you try to use them the first way, since you're using parentheses, it thinks that it's topic style. Since you don't have the token, the sharp token, that will fall to syntax error. So the good way to do this is on the second example here. This is cool because
here comes a new challenger.
We have a new challenger. So that is the F# pipeline proposals, the other competing proposal. It just extends the minimal proposal with an await step. You can see on this example here, you have just a solo await step here, and this means that it needs to await for the previous step to be finished. Then, as soon as the previous step is finished, then it passes further to the next step. You still can see here that we still have the arrow function being wrapped with the parentheses, but this I will show you how can we solve this just in a couple of minutes. When we were discussing pipeline operator, we saw this example here with the sharp as a token. We can do this, we can solve this, this line with partial application, but first I need to explain to you what is partial application. Partial application refers to a process of giving a function with any additive. It returns another function with a smaller additive by bounding the fixed parameters. Additive, by the way, is the number of the parameters that a specific function takes. So I have this example here with a function say hi, then receive 3 parameters, the greetings, the name, and location, just console log those. But what if this example like this is just straightforward, but what if I need to fetch the location for the server? I don't know why. But then we may end up with this kind of code that we have some parameters like that we assigned before, and then whenever we have this promise chain resolved, we console log it or call the function. This is kind of verbose, but we still have a way to bind this and create a partial application in ECMAScript. So we can do this using function prototype.bind. Sometimes we forgot that not only binds the context, but binds as well the parameters. So the first parameter the bind receives the context, and the following parameter is the parameters for the function you want to call. But this binds these parameters to this, and returns a new function just with the remaining missing parameters. So with this, I can rewrite that function using this bind. So on the first line, you can see that this is achievable. But what if I want to bind just the first and the last parameter? There is a problem with the bind operator because, the bind function. It takes the parameters from the left to right without jump any one of those. So this is a problem. And someone can say, yeah, but we can solve this with curry. Yes, we can. But you need to remember that even though currying, it's a way to achieve partial application, doesn't mean that currying is partial application. Currying, each time you curry a function, we receive another function that's additive n-1. And so that previous example, let's say I want to just bind the first and the last parameter, so I can write on these three first lines of code. I can create like this curry function that receive the greetings, then the location, then on the line 5, I will bind just these two first parameters, then I will receive the function to bind to call with the third one on the line 8. So you can see that it's kind of verbose, because whenever you want to change the configuration parameter that you want to bind, you need to rewrite that curry function there. Yes, and you can, of course, you can do this as well with the partial application, or with the arrow function, which it's kind of better than the curry function, but still need to write the function for each configuration of parameters. So this is the hook for our last proposal for today. Partial application. Partial application proposal creates two new tokens to be placed inside the parameters. So the question mark is for single argument, and the ellipsis is for multiple arguments. So the previous example could be here written this way. So you have the first, the second parameters being bound, and the third one you put a question mark. This will return a new function that you can call later with the missing parameters. It's nice because you can do a lot of different configurations of parameters without having to any kind of boilerplate code. But wait, there is more. There is this ellipsis token. It spreads the unbound parameters on the specific position. It's very useful whenever you want to bind like the first parameters, and you don't need to care about the rest of those or the last one. So I have an example here. For example, this is a function that it's max greater than 0. So I receive a bunch of numbers, and I need to return, whenever I have a number greater than 0, I return the max of those. Whenever I will only receive negative numbers, I return 0. So this one, it's still okay, but we can do better. With this, we can bind just the 0 as a first parameter, and then don't care about the rest. And then this will return a function thus with 0 being bound. And this is nice because it doesn't matter how I can call it. If I call in the first configuration, we return the same as before. And since 0 is already bound to math.max, I will receive 0 whenever I just send just negative numbers. We still have this this configuration on the F# proposal, and I told you that it's kind of a syntax overhead to wrap an arrow function with this parenthesis. But with partial application, we can rewrite this line 4 to this, and we have like a more pre-code readable one. So then you may ask me, should I use all of this amazing stuff on production? No. These proposals are in very early stage. Not that I showed you is even in stage 2. Is the Python operator is just stage 0, and the other 2 is in stage 1. There is a lot of conversations to be done in order to fix that syntax semantics. The adoption of one form of one proposal may shape the syntax and semantics of the other, or even remove completely. So my point here is call you to participate with this discussion. On my second slide, I will share with you later on. There is the link for TC39 proposals page. Whenever we wanted to show your interest on some proposals or express your concerns, open issue, put stars, create a talk about it, as I did. Before I finish, I want to thank that guy, Bernard Bush, who was the guy who helped me with this designs, because as a JavaScript development bad designer. And this guy here, Daniel, sadly he is behind me. Little Dan helped me with the technical stuff, like to don't introduce any misconceptions to you. These are my contacts if you want to get in touch with me. I will try to in the next weeks write all of this in an article that may help you to understand more about it. And with this, I thank all of you.